one of the most vital discoveries made by man, a discovery that made a difference between darkness and light, or even life and death. The flame was perhaps one of the first chemical reactions recognized, controlled, and harnessed by man, a chemical reaction in which energy is released in the form of heat and light. Every single example of flame that we see here begins with carbon or a carbon compound. The carbon compound, such as methane, combines with oxygen in the air to produce an oxide of carbon, that is, carbon monoxide or carbon dioxide, along with water. And each of these reactions results in the liberation of energy in the form of heat and light. Such chemical reactions in which heat is released along with the formation of products are known as the exothermic reactions. However, for an exothermic reaction to occur, it is not necessary that we have only carbon or its compound as one of the reactants. Let us perform an experiment to prove this. Wasn't that dramatic? The reaction of sodium metal with water is an exothermic reaction, that is, a reaction in which heat is released. This experiment should be carried out very carefully because the piece of sodium metal can splutter when dropped into water, and to prevent this, we should take a very small piece of sodium metal for this experiment. In fact, sodium metal is very reactive. It reacts even with a trace of moisture present around, and for this very reason, it is always stored under kerosene or coated with wax. The reaction of sodium metal with water is an exothermic reaction, that is, a reaction in which heat is released. There are reactions of the opposite kind. These are the reactions in which energy is absorbed in the form of heat. These reactions are called endothermic reactions. Let us observe one such reaction. Now let's take some citric acid into the conical flask. And measure its temperature. It's 16 degrees Celsius. And now let's add some baking soda, sodium bicarbonate, commonly used at our homes. Are you observing the reaction occurring? Brisk effervescence are coming out. And now let's also see what's the temperature. So we can say the temperature is 12.5 degrees Celsius. And as the temperature has come down during this reaction, this indicates that heat was absorbed during the reaction between citric acid and sodium bicarbonate, and hence this is a endothermic reaction. Now let us observe few more interesting examples of exothermic and endothermic reactions. All these experiments can be carried out very easily in the chemistry lab of your school. Observe each of the experiment very carefully, particularly the precautions being taken. Let us observe a reaction between ethanoic acid and sodium carbonate now. Ethanoic acid is commonly used as vinegar at home, also known as acetic acid, and sodium carbonate is used as washing soda. Let's take the temperature, and the temperature of ethanoic acid is 20 degrees Celsius. Now let's see what happens when we add sodium carbonate, the washing soda. Again brisk effervescence. And what about the temperature? The temperature has risen. It is 21 degrees Celsius. This means that heat was evolved during the reaction between ethanoic acid and sodium carbonate. Hence, this is an exothermic reaction. Let us now observe a reaction between calcium oxide, that is quicklime or chuna that we use for whitewashing, with water. So much heat is generated during the reaction that water starts boiling. It is an exothermic reaction. Let's do one more reaction. We have dilute hydrochloric acid and sodium hydroxide. Dilute hydrochloric acid in the conical flask, and sodium hydroxide in the beaker. Let's take the temperature. The temperature is 20 degrees Celsius. We should always wash the thermometer before dipping into another solution. And the temperature of sodium hydroxide, it is also 20 degrees Celsius. Now, let's mix the base with the acid and measure the temperature. I can feel the conical flask getting warm, and the temperature is rising very sharply. It has moved to 36 degrees Celsius. That means, again, the heat was evolved during the reaction, and the reaction of hydrochloric acid, which is a strong acid, with the base is an exothermic reaction. Now, let us observe another reaction between potassium permanganate and glycerine. Before doing the reaction, we'll have to powder potassium permanganate so that the reaction is fast. Look, it has caught fire. It is a very dangerous experiment, and under no circumstances you should carry it out alone without your teacher's assistance. The burning or oxidation of a metal is also an exothermic reaction. Let's observe burning of magnesium ribbon. Magnesium ribbon always hold the ribbon away from you. See how it burns with a dazzling white flame, forming ashes of magnesium oxide. Never look directly into the flame of burning magnesium. We have observed a number of exothermic reactions. Now let us observe some endothermic reactions. Endothermic reactions are relatively less common. The reaction between potassium chloride and ammonium nitrate is an endothermic reaction. Let us mix the two salts, potassium chloride and ammonium nitrate, and stir and observe the change in temperature. As the reaction is between two solids, we have to take care that the two reactants are nicely powdered. And to enhance the reaction, we can add a drop or two of water. The beaker has become too cold to touch. Now let us observe what's the change in temperature. The temperature has already dipped to approximately -2 degrees Celsius. It is an endothermic reaction. Let us try another experiment. This time we will take barium hydroxide and ammonium nitrate in the ratio 2:1. The temperature of barium hydroxide powder is 17 degrees Celsius. The temperature of ammonium nitrate is also 17 degrees Celsius. Let us mix the two powders and observe what happens.
barium hydroxide and ammonium nitrate in the ratio 2:1. Stir the mixtures and observe what happens. The beaker is becoming cold. The temperature has already dropped to below -10 degrees Celsius. It's an endothermic reaction.
We have seen certain reactions which are exothermic and others which are endothermic. Some of them were really spectacular, isn't it? Now we should understand why heat is absorbed or evolved during a reaction. For this, we should first try and understand how a reaction occurs. During a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and then reformation of bonds between atoms to produce new substances. Let us take the example of the complete combustion of a carbon compound, methane. Methane combines with oxygen, producing carbon dioxide and water. The methane molecule consists of a carbon atom bonded to 4 hydrogen atoms. Oxygen has 2 oxygen atoms bonded to each other by a double bond. During the reaction of methane with oxygen, carbon-hydrogen bonds of methane break and oxygen-oxygen bonds of oxygen also break. Then, new bonds are formed between carbon-oxygen and hydrogen-oxygen to give the products of the reaction. To break a bond, that is, to pull 2 atoms apart, energy is required, whereas when the 2 atoms combine together, energy is released. Now, during a reaction, if the energy released is much more than the energy required to break the bond, the excess energy is released to the surroundings, and we call such a reaction as an exothermic reaction. On the other hand, there are reactions in which the energy required to break the bonds is much more than the energy released during formation of the bonds. In such reactions, the energy is absorbed from the surroundings, and so the temperature of the surroundings drops. Such reactions are the endothermic reactions. We have now understood why certain reactions are exothermic while others are endothermic. Let us briefly summarize what all we have learned. We have also observed many exothermic and endothermic reactions. Do learn to perform these experiments, but be extremely careful while handling apparatus and chemicals. And most importantly, do all these experiments under the supervision of your teacher only. Happy experimenting!